Alrighty, so here we are with the 4-6 Slope-Intercept Form notes for intermediate algebra. Our objectives today are to write a linear equation in slope-intercept form. We've kind of started out doing a bit of that, and then we're going to graph a line using that slope-intercept form. So here we are with a breakdown of the slope-intercept form. Again, we kind of started it the other day, but remember that we are going to be seeing this y equals mx plus b. So y, of course, is our dependent variable, always going to be there. X is our independent variable. It's what we would plug something into in order to get the dependent variable. B ends up being our y-intercept, and m is our slope. All right. So any linear equation that can be written in this slope-intercept form by solving for y and simplifying. So you can always take every equation that happens to be in this linear format, and you can write it into slope-intercept form. It's generally what we call our most used foundation, but of course you do have the actual standard notation, so I wouldn't call this standard, I would just call it our general format. We usually revert to this. So in this form you can immediately see the slope and the y-intercept, very helpful. And so you can quickly graph a line. So again, this format, it's helpful for once we start graphing on graphing calculators and things like that. They do all end up trying to make you write y equals anyway. So we do want to have that practice in order to be able to rewrite them. So here's the first one here. And again, we did do a lot of this in our previous chapters of moving things around in order to get to isolate something. So in this case, we're trying to isolate the y because we want it to eventually be y equals something. And again, we want it to be y equals the slope right next to the x, and then to that we would add the intercept. Okay. So as we look through how to rewrite this, remember that we are going to be doing SADMEP because we are solving something. So that means that I'm looking for addition and subtraction. So what is being added to this y? Well, it's technically negative 12x. So how do we get the opposite of negative 12x? The opposite of negative 12 is going to be adding 12. So we're going to add 12x to both sides. And remember that we're trying to get it in this format. So if we add a 12x, I'm going to write that first, and then I'm going to say plus 6. So in that case, our left side stays 3 and y, and then our right side is going to be this 12x, but then plus that 6, because we do want to keep the x first. All right, then our next step is going to be to move that 3. So that 3 is in the division multiplication step. So we're going to undo the division, undo the multiplication with division, and of course every number is divided by 3. So when we get to our answer here, we are going to have y equals, and 12 divided by 3 is going to simplify to be 4, and then 6 divided by 3 is going to simplify to be 2. So we know very easily that 2 is our y-intercept, and 4 is our slope. And again, the slope came from m, and the y-intercept is this b. That's kind of a ugly 4 there. All right. So the next thing that they want you to do is, instead of find the pieces, they want you to use the pieces to make the equation. So remember that our equation is y equals mx plus b. And since they're telling us that our b value, or our y-intercept, is 4, we'll replace b with 4. And then they're telling us that our slope, or our m, is a 4th. All we need to do is rewrite this with, instead of an m, a 1/4, and instead of a b, a 4. There it is. All right. The next one here, we want to talk about this line and how we can get the slope, write the formula from this graph. This is just a review page, so if I'm going to use a formula to find slope, My slope is going to represent the fact that this is an x1 and a y1 point, and this is an x2 and a y2 point. And so I'm going to take y2, subtract y1, and divide that by x2 minus x1. From the graph, though, the slope ends up being your rise over your run. And of course, rise can be negative if we're talking about going down, and run can be negative if you're talking about going left. Otherwise, we kind of think of it as positives if we're going up and to the right. All right, so using this idea, we're going to go ahead and write the slope-intercept form equation from this graph. So anytime that I can use rise over run, definitely usually use that one. So if slope is rise over run, I'm going to rise 1, 2, 3 dots and run 1, 2 dots. And so my slope is 3/2. The other piece that's in here is this y-intercept. And so my y-intercept is at the coordinate of 0, 1. And so that means that b is 1. So writing the equation, I'm going to fill in that my slope is 3/2 and that my b value is 1. So again, very easy when it's in this on a graph, writing it in this formula, because you can see the slope, you can see the intercept, and so it's a great correlation. All right, the next one here, just kind of a little reminder, an equation needs an x and a y, okay? So as I'm looking at this equation that I wrote, notice that I kept it in yellow kind of every time that we were doing this, because I wanted to be sure that we understood that as much as there are an x and a y, you do need that in your equation in order for it to be an equation, otherwise it's just a statement. So, if we want to write the slope-intercept form of an equation with a line that has slope of 2, knowing that 4, 7 is on the line, this one's a little bit different because it is not the intercept. So, unlike the previous example where we had our intercept very visible, we are now actually not having that. And so we could graph this, but of course we're not given graph paper, so we use kind of what we have. But if you have graph paper, you can go ahead and plot this point and kind of move the slope in order to get to the intercept. So we're going to do it a different way. We know that y equals mx plus b is our equation, and the interesting part is that they give us an m of 2, and they technically give us an x and a y. And so if I fill in each of those pieces, I have a y of 7, I have a slope of 2, I have an x of 4, and then the leftover is that there's a b. And so now that we have a statement that only has one variable in it, we can actually just solve for that variable. So for instance, if I simplify 2 times 4, I actually have 8 plus b. And then if I continue to solve and subtract the 8 over, I now have a b that is -1. So I can use this idea from this point existing in the equation that I'm given. It's just that instead of being given a slope and an intercept, they're giving you a slope and a point. And so that's okay, you can move on from that. So in that case, our equation, remember we just said, needs to have an x and a y in it. So that's going to be y equals and a slope times x. Alright, and then of course our slope goes in here, which we just found out from the problem itself is 2. So if we put our 2 here, and then we just found out from solving that our b is actually -1, so we can go ahead and put that in. Of course, if I'm going to put -1, I can just say subtracting 1 instead of plus negative. So that's our equation. So this could have been written as knowing that our slope is 2 and our y-intercept is 1, sorry, -1, but of course we had to solve in order to find that. All right, just so that we have a reminder, and I did go over this in our Zoom the other day, if you have a negative sign, most of the time when we type or when you're kind of looking at a document that I've made or that the book has made, you actually end up seeing the negative out front. Most of the time, however, when we write it, we just end up putting our negative in the top. And it turns out that these are both equal. Sorry, that's not equal. That is. And so it's okay if it's up at the top. That's fine. It's also okay if the negative is at the bottom, because that might also happen as well, versus out front. Okay, so either way, the idea is that all of them are equal. The problem that happens, though, is that sometimes people will say, oh, well, then I'll just put it on the top and the bottom. But that's actually positive 2/5 if you divide two negatives, so we can't really have that. Also, some people will put all three of them, which actually is equal, but again, kind of redundant. So just make sure that you understand that you can have a negative out front, on top, or bottom, and it's all the same in your fraction. All right. The next one is that we are going to graph the equation. So now instead of given the graph, we're going to make the graph. So if we make a graph from what they give us, which is the slope and the y-intercept, we start with the y-intercept, and then we move the slope. So if we start at the y-intercept, that means that we're starting at the point 0, 4, because it's on the y-axis, right? Y-intercept on the y-axis. Then if we're going to move, notice that we have negative 2/5, and so I'm actually going to put the negative up top and talk about how that means we're going to run a certain amount and how we're going to rise and run. Wow, I just flipped that around. And so technically from this point that I've made, I'm going to rise down 2 and go right 5 when I move. So if I go down 2 and right 5, my new point is there. And then I get to do that as many times as my grid shows. Technically you only need 2 dots to make a line, but I like to be as precise as possible. So if we go down 2 and over 5 again, the next point is here. Anytime that you're graphing, you always want to double check, just anytime you want to double check that what you're looking at makes sense. For instance, this is a negative slope, and this is a line that's actually negative, because sometimes we get a little flipped around. So, double checking that it's negative, double checking that it started, even though I can't draw a straight line, at that intercept, etc., etc. So, that's what we're looking at. Hopefully that helps you out with 4/6 and your slope-intercept form, and we'll see the assignment tomorrow.